The next topic is finding the trig functions of angles. So there's really two ways to do that. There's the unit circle and then there's the reference triangles. So in this course we're going to be focusing on mostly the unit circle, but if you learned using the reference triangles, then that's totally okay as well. So the reference triangles, you can project it into all four quadrants and change the appropriate signs, and it serves the same purpose as the unit circle. So either way is okay. The unit circle, you'll notice that we have all these points, and these points are all associated with angle measurements as well. And the unit circle, by definition, is a circle of radius 1 centered at the origin, and its equation is x squared plus y squared is equal to 1. So if you were to take each of these x and y coordinates, and if you were to square them and add them up, they equal 1. So this x and y, if you square them and add them together, they equal 1. This x and y coordinates, if you square them and add them together, they equal 1. And it's the same for any xy points on the unit circle. The reference triangle, you have a 45, 45, 90, and you have a 30, 60, 90. And these angles occur very often, and the triangles are used for many things, including drafting. So if you ever take like a drafting course for like mechanical drawing, then you will know that you have these two triangles, and they are used to draw many different angles and do other kinds of things. So the 45, 45, 90 is derived by cutting a 1 by 1 square down the diagonal, and the 30, 60, 90 is derived by cutting an equilateral triangle with sides 2 down the middle. So I'm not going to go into the full proof of them, but if you've taken trig before, they will have talked about where those two come from. Okay, so since the circumference of the unit circle is 2 pi, or 360, negative and large angles do not appear on the unit circle. So again, it's like you go from 0 all the way to 360 or to 2 pi. But I don't see any negative angles on here, and I don't see any angles bigger than 360. So to find these angles, 2 pi or 360, depending on if you're dealing with radians or degrees, can be added or subtracted as many times as necessary to get an equivalent, or what's called a coterminal angle, that is between 0 and 2 pi or 360. So for many angles, we're going to have to find the coterminal angle, or the equivalent angle, that is on the unit circle in order to use the unit circle. To find the trig functions on the unit circle, we use this template where sine is equal to y, cosine is equal to x, tangent is equal to y over x, and then the reciprocals are the reciprocals. So because of these reciprocals, if a denominator is 0, because we do have some fractions here, then the trig function is undefined at that point. Again, like we talked about, sine and cosecant, cosine and secant, tangent and cotangent, these pairs are all reciprocal functions. And then also trig functions are sometimes called circular functions. They don't call it that very often, but sometimes you will hear it be called circular functions. And this is because they can be defined using the unit circle. Okay, so getting to an actual problem 14, if you're asked to find what is the sine of 60 degrees, and if you want to use the unit circle, then the unit circle again tells you to pick the y. So the y value of 60 degrees, if you find 60 degrees, here it is, the y value of that point is square root of 3 over 2. So sine of 60 degrees is equal to square root of 3 over 2, and that would be your answer.